So we started the matrices topic, and then today we are going to find the inverse of matrix. Find the inverse of matrices. So by inverse, we mean that by inverse of matrix A, we mean that it is a matrix when we will multiply that A by its inverse, which is represented by this A minus 1, then we will get an identity matrix. Okay, so there is an algorithm for finding the inverse of matrix, and that algorithm, if we will adopt, then we can find the inverse of the matrix. So remember that before this, there is a topic of linear transformations. I will upload that topic separately. However, today we are talking about the inverse of the matrix. So not every matrix has the inverse. Only the square matrices have the inverse. That means for those matrices for which the number of rows and number of columns are the same. Okay, so suppose if we want to find the inverse of a matrix, say if the matrix is say A, B, C, D. So if we want to find its inverse, so then we can write this matrix in its augmented matrix form, A, B, C, D, and its augmented matrix form for finding the inverse of the matrix will be that we will write the unit matrix, okay, with that given matrix. So since A, B, C, D is a 2 by 2 matrix, so we will write a 2 by 2 unit matrix with that. So that now we will apply the row operations on this augmented matrix. So for finding for the row operation, then what we will do is, first of all, we will divide the first row by A to make A as 1. So suppose that A is not 0. Okay, so A divided by A, so B over A is equal, so this will be the B over A, then it will be 1 over A, and then it will be 0. So we have divided the first row by A. Okay, so C, D, 0, 1. So now to make this C as 0, so we will multiply the first row by C and then subtract from the second row. So it will be 1 B over A, 1 over A, 0. So it will be 0. And then it will be D minus BC over A. Okay, and then it will be minus C over A, and then it will be 1. Okay, so the row operations. And now what we need to do is we need to make this as 1. Okay, so in order to make this as 1, so that let me simplify it a little bit. So this is AD minus BC over A. Okay, so this means that I need to multiply this row by AD minus BC. Okay, so 1 over B over A, 1 over A, 0, and then 0, and then we will multiply by A over AD minus BC. So it will be 1, and then this will be minus C over A into A. And so that means when we multiply with minus C over A, so that means A over BC. So it will be minus C over A times A over AD minus BC. So this will be the first one. And then it will be A over AD minus BC. Okay, so, and then this will be 0. This will be 0. So now in order to make this B over A as 0, so what you will do is I will multiply this row by a B over A and then add it to this row. So it will be 1 and then 0 and then 0 and 1. And now over here, so since I have multiplied it by B over A, so what is this value? So this is minus C, A cancels with A, so it is minus C over AD minus BC. And then I have multiplied it by B over A, minus B over A, okay, minus B over A. So it will be BC over AD minus BC, okay, it will be, then this value will be BC over AD minus BC, and then that is being added to this value 1 over A, so plus 1 over A. So what I will get is, so this makes it a little bit complicated over here. So A into AD minus BC, so it is BC plus, then that will be AD minus BC. So BC cancels with BC, so it will remain AD over A. So it will be now AD over AD minus BC. Okay, so this will be then, what will be this value? C over AD minus BC, okay? And then it will be now, so since this value will be now multiplied with what? A over AD minus BC, okay? Then that will be multiplied by what? Minus B over A. So A cancels with A, and then that is added to this. So it will be plus, it will be minus B over it will be minus B over AD minus BC. And then it will be also, because this is multiplied by that, so it will be A over, no, it will be B over, so it will be minus B over AD minus BC. So in this way, we will get the inverse of the matrix. So in this case, in this inverse of the matrix, I can see that 1 over AD minus BC is common in each term. Okay, AD minus BC is common in each term. And here I will have is D, and here I will have is minus B and minus C. And here I will have is A. Okay, so in this way, I will get this formula. In fact, I have made some, I think maybe some calculation mistake. The final answer should be like this. Okay, so I think later on you can check it by yourself. By adopting the same procedure, the final answer should be something like this. But I think I have made some mistake somewhere in the computations. But let's, you can check it, verify it later on. So final answer should be like that. Maybe I have made some mistake, but anyway. So let's see some examples for the inverse of the matrix, numerical examples. So this I just did to show for the 2 by 2 matrix, you can find by a formula the inverse of the matrix as well. So anyway, so as a numerical example, let's say if the matrix is something like this. Example, if you have a 2 by 2 matrix A, which is 2, 1, and 1, 1. Okay, we want to find its inverse. Okay, so its inverse we can find by the row operations 2, 1, 1, 1, and its augmented matrix is with 1, 0, 0, 1, and then we will apply the row operation. So first of all, we will divide throughout by 2. So it will be 1, 1 by 2, 1 by 2, 0. Okay, and then it will be 1, 1, 0, 1 as it is. So the row operation is 1 by 2, row 1 is new row 1. Okay, the next row operation will be that we have to make this as 0. So it will be, the next row operation will be minus R1 plus R2, that will be new R2. So in this case, what I can do is 1, 1 by 2, 1 by 2, 0, that is the first row. And then this will be 0, 1 minus 1 by 2 is 1 by 2, 0 minus 1 by 2 is minus 1 by 2, and 1 minus 0 is 1. Okay. So now the next row operation is I have to make this value as 1. So multiply second row by 2, so that will be the new second row. So let me write it over here. So 1, 1 by 2, 1 by 2, 0, 0, 1, minus 1, and then 2. Okay. And then the next row operation will be to make this as 0, so that the left hand side will be a unit matrix 1, 0, 0, 1. So for this, the row operation will be what will be the row operation? Minus 1 by 2 row 2. Okay, so it will be minus 1 by 2 row 2 plus row 1. Okay, this will be the row operation. So in this case, it will be then 1, 0, and then because it will be minus 1 by 2 row 2, so it will be then plus 1 by 2, plus 1 by 2, plus 1 by 2 is 1. And then this is, since it was minus 1 by 2, so it will be minus 1 plus 0 is minus 1. Okay, and then it will be 1, 0, 1, minus 1 and 2. So therefore, we will find that A inverse is, in this case, is 1, minus 1, minus 1, and 1, minus 1, minus 1 and 2, minus 1 and 2. So 1, minus 1, minus 1 and 2. So if A is 2, 1, 1, A is 2, 1, 1, 1, then the A inverse is, we have found out, is 1, minus 1, minus 1 and 2. So for this 2 by 2 matrix case, so for example, now we have, let me write the results. So A was 2, 1, 1, 1, and we found out that A inverse is 1, minus 1, minus 1 and 2. Okay, so we can verify it, although it is not necessary, but just to see what's happening. So A inverse, it will be equal to 2, 1, 1, 1, 1, minus 1, minus 1, 2. So what it will be? It will be 2 times 1, 2 times 1 plus 1 times minus 1, and then it will be 2 times minus 2 plus 1 times 2. So row, column, row, column, row, column. Okay, 1 into 1 plus 1 into minus 1, and then plus 1 into minus 2 plus 1 into 2. So what we get is 2 minus 1 is 1, minus 4. So it may be I made a mistake over here. So 2 into minus 2 is this. It was, sorry, it was A inverse was minus 1. Okay. So A inverse was minus 1. A inverse was minus 1. So it will be, okay, 2 into 1 plus 1 into minus 1, 2 into minus 1, and then 2 into, then 1 into 2, okay? And then it will be 1 into 1 plus 1 into minus 1 plus 1 into minus 1, so it will be minus 1, and then plus 1 into 2. So now it will be 2 minus 1 is 1, so it will be minus 2 plus 2 is 0, and then it will be 1 minus 1 is 0, and then minus 2 plus 2, so it will be minus 2, again, check it again, okay, 1 into minus 1 is minus 1, so it will be minus 1. Minus 1. So minus 1 plus 2 is 1. So 1, 0, 0, 1. Okay, so for a 2 by 2 matrix, so we have the inverse formula as well. So as I tried to derive previously, but due to some mistake, I could not derive it. But anyway, you can check it later on. So that for 2 by 2 matrix, the inverse formula is 1 over AD minus BC into, if for example, A is A, B, C, D. So the easy way to remember is that A and D are replaced with each other. So in place of A, you put D, and in place of D, you place A. And then the signs of B and C change. Okay, so if we apply this formula on this matrix, or maybe on the inverse, so we can get the other one. So for example, if I want to find A inverse, so what is AD minus BC? AD is A, this is A, this is D, this is D, this is C. Okay, so it is, what is this? 2 into 1 minus 1 into 1 into, now D, what is D? D is now 1, and A will be here, and then this will be, these two values will change sign. So now what we get is 2 minus 1. So that is actually 1. So what we get is 1 minus 1 minus 1, 2. So which is the same as this, okay? On the other hand, if we have the A inverse, we can find A from this formula as well. So because A inverse is equal to A inverse A, okay? Both way it is possible. So we can find it. Any questions? Do you have any questions?
No questions.
No.
No questions. Okay. Okay. If, for example, if we have a matrix, something like B, 3, 2, minus 1, 5, 0, 1. So what is B inverse? So in this case, we will say that the inverse of B is not possible, okay? Not existing, not possible, or not defined. Because the inverse of any matrix is defined for a square matrix, okay? So let's do one 3 by 3 example, okay? 3 by 3 matrix example, okay? So C, if C is, for example, is equal to 1, 0, minus 2, 2, 1, 2, and 2, 1, 3. So how to find its inverse? So the first step is write its augmented matrix 1 0 minus 2 2 1 2 2 1 3, and its augmented matrix will be written by like this 1 0 0 0 1 0 0 0 1. Okay, after writing the augmented matrix, we will apply the row operations. So first row operation will be that, because this will be the pivot position in 1, and we need to make these 2's as 0. So it will be minus 2R1 plus R2, that will be the new R2, and then minus 2R1 plus R3, that will be the new R3. Okay, so in this case, what we can do is we can make it as zeros. Okay, so in this way, then what we get is 1 0 minus 2 and 1 0 0, and then we will get 0 1 6 minus 2 1 0, and then I will get 0 1 7 minus 2 0 1. Okay, so you can check the calculations if it is correct or not. So the next step is to make this as 0. Okay, this 1 as 0, because this is already 1. So I will apply a row operation minus R2 plus R3, that will be R3. Okay, so in this way, what I will get is 1 0 minus 2 1 0 0, and then 0 1 6 minus 2 1 0, and then it will be 0 0 1. Okay, sorry, it will be 0 0 1 and 0 minus 1 1. So fortunately now this all of these pivot positions are 1, but now I need to make these two values as 0. Okay, 6 and minus 2. So for this, what I will do is I will take minus 6 row 3 plus row 2, that will be the new row 2, and then I will take 2 row 3 plus row 1, that will be the new row 1. Okay, so now in this, when I do like this way, it will be 1 0 0, it will be then 1 minus 2 2, and it will be 0 1 0, and then minus 2 7 minus 6, and then it will be 0 0 1 0 minus 1 1. So in this way, now I can see that the left hand side is already a unit matrix. So the right hand side will be the inverse of this given matrix C. So C inverse will be 1 minus 2 2 minus 2 7 minus 6 0 minus 1 1. So this is the method for this is how you will find the inverse of the matrix using the row operations. Using the row operations. Okay, so another example. Let's see if the matrix D is say yeah minus 3 6 1 minus 2, and since this is a 2 by 2 matrix, so its D inverse can be found by this formula 1 over AD minus BC, or you can apply the row operations. Any of the method would work. Okay, minus B minus C A, and suppose that D is represented by A B C D. But in this case, if we find AD minus BC, AD minus BC, AD is A is this minus 3, D is minus 2, and minus B is 6 and C is 1, we will get 0. So if AD minus BC is 0, if AD minus BC is 0, it means that in the formula we will be dividing by 0. So that is not defined. So it means that we will say that D inverse does not exist. Okay. And then we can see it with the help of row operations as well. So minus 3, 6, 1, minus 2. If we apply the row operation on that, what I will do is first row operation will be minus 1 by 3. Row 1, that will be the row 1. So it will be 1 minus 2. Okay. 1 minus 2, 1 minus 2. And now the second row operation will be to make this as 0. So minus R1 plus R2, that will be the new row R2. So here in this case, we will get 1 minus 2, and but you will get 0, 0 in the second row. Okay, so when you the second row or any of the row is completely 0, then there is no further simplifications possible. That means that you cannot find the inverse of the matrix in this case. Okay. Okay. So next one is a 4 by 4 matrix, but it's slightly simplified. I mean, the more the order of the matrix, more complicated it becomes to find the matrices. So therefore, the use of Mathematica or other software is indispensable in finding the inverse of the matrices. So suppose if F is like this, 1, 3, minus 2, 0, then it is the second row is 0, 1, 1, 0, 1, 1, 1. The third row is 0, 0, 1, minus 4. And the last row is 0, 0, 0, 1. So you can see that this is an upper triangular matrix. Okay. This is an upper triangular matrix. Okay, so many of these terms are zeros. So if we want to find its inverse, so what I can do is I can write the augmented unit matrix over here. So it will be 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, and then it will be 0, 0, 0, 1. Okay. So in this case, I have this augmented matrix. So what will be the first row operation? So I think I don't need to do any row operations on the lower part of this matrix. So I have to go from the top down, because actually the matrix is already in the echelon form, but we have to convert it into the reduced echelon form. Okay, so first our row operations will start from this row number 4. So row number 4 multiplied by 4 times row number 4, and then add to row number 3. So it will be the row number 3. So this will make this 4 as 0, and then I need to make this 1 as 0 as well. So this will be the operation will be minus row number 4 plus row number 2 is equal to row 2. And this is already 0, so we don't have to make any operation in this case. So in this case, it will become 1, 3, minus 2, 0, 1, 0, 0, 0. And the last row will be 0, 0, 0, 1. This will be 0, 0, 0, 1. And then the changes will be in the row number 3 and row number 2. So what will be those changes? So since I took like 4 times of this, so this will then become 0, 0, 1, 0, and then 4 times of this plus this. So it will be 0, 0, and 1, and then it will be 4 over here. Okay, it will be 4 over here. And then for the second row, it will be, what I did was I took these, subtracted it from this. So it will be, second row will be then 0, 1, 1, and then 0. And then I subtracted this from here. So 0, then it will be 1, and then it will be 0, and then it will be, now here the value will be -1 because I took minus of this row and then added to here. So 0, 1, 0, -1 over here. Okay, so now I need to make I need to make, I will move to here, and then I need to make these two values as 0. Okay, so in this case, what I will do is I will take a minus row 3 plus row 2, so that will be the new row 2. And then I will take 2 times of row 3 plus row 1, that will be the new row 1. Okay, so in this case now row 1 and row 2 will change, and then row 4 and row 3 will remain the same. So I will write them down as it is: 0, 0, 1, 0, 0, 0, 1, and it will be 0, 0, 1, 0, 0, 0, 1, 4. And now the row 2 and row 1 will change. So it will be changed like this. So I subtracted this out. So this will be 0, 1, 0, and then it will be 0. And then it will be 0 minus 0 is 0. 1 minus 0 is 1. 0 minus 1 is, now it will be -1. And then -1 minus 4, it will be -5. Okay. And here the first row will be now 1, 3 minus, so this will be 0. Yeah, because we multiplied it by 2, and then and then this will be 0. So let's separate it out. And 1, 3, 0, 0. And then here I will get like 1 as before. Here it will be 0. Everything will be 0. And then here I will get what? So because it was 2, okay? 2 times R3, so it will be 2. And then 4 times 2 is 8 plus 0 is 8. Okay. Okay, so now what I look at, when I look at over here, only this 3 is something which remains to be zeroed. Okay, so in this case now what I will do is, what I will do, minus minus 3 times row 2 plus row 1, that will be the new row 1. Okay, that will be the new row 1. So in this case, again, now these 3 rows will remain the same, the second, third, and fourth. So 0, 1, 0, 0. It will be 0, 0, 1, 0, and then it will be 0, 0, 0, 1. And then corresponding values 0, 1, minus 1, minus 5. And that it will be 0, 0, 1, 4. It will be 0, 0, 0, 1. And the first row will change. So now I wanted to make this as 0. So it will be 1. And then 1 minus 3, I multiplied by -3. So it will be 0. And since these two values were 0, so it will be 0, 0 over here. This value was 0, so it will remain as 1. So this was -3. So minus 3 plus 0 is minus 3. And this was minus 1. Minus 3 times minus 1, minus 3 is plus 3. 3 plus 2 is 5. And here, now it is multiplied by minus 3. So it will be plus 15. 15 plus 8 is 23. Okay, so here I have got the inverse matrix. So this is the inverse matrix, okay? So this is the inverse of the matrix, okay? Which of the given matrix. So of course, this can be verified by multiplication of these two matrices, and then we should get a unit matrix of order 4. Okay, so this is how we find the inverse of the matrix. Okay, so the inverse of the matrix can be used to find the system of the linear equations. Okay, so for example, if we have the system of linear equation as something like this: x1 minus x2, sorry, x1 minus 2 x3 is equal to 5. 2x1 plus x2 plus 2x3 is equal to 1, and 2x1 plus x2 plus 3x3 is equal to minus 2. So using the inverse matrix technique, so we can find its solution. How this system can be written as something like this: Ax is equal to B. So where A is the matrix of these coefficients of x1, x2, and x3. So it will be 1. Coefficient of x2 will be 0. So 1, 0 minus 2. 1, 0 minus 2. And it will be 2, 1, 2, 1, 2. And then 2, 1, 3. And x will be a vector x1, x2, x3. And b will be these coefficients on the right hand side: 5, 1, minus 2. So when we can say that Ax is equal to B, then we can also say that x is equal to A inverse of B. So if, for example, if we have A, we can find A inverse and then multiply it with B, then we can find the solution. So this is the same matrix which we did before: 1, 0, minus 2. So here you can see that 1, 0, minus 2, 2, 1, 2, 2, 1, 3. Okay, 1, 0, minus 2, 2, 1, 2, 2, 1, 3. So its inverse we already have found. So we know that its inverse we have found before. Its inverse was here. Yeah, 1 minus 2, 2, minus 2, 7, minus 6, and 0 minus 1, 1. Okay, so its inverse was this. So 1 minus 2, 2, minus 2, 7, minus 6, and 0 minus 1, 1. So now if we take this inverse matrix and multiply it with the matrix B, 5, 1, 2. So the multiplication of that will be the solution. So our solution will be down, in this case, it will be 1 into 5 plus minus 2 into 1 plus 2 into 2. And then minus 2 into 5 plus 7 into 1 minus 6 into 2. And then 0 into 5 minus 1 into 1, and then plus 1 into 2. So by simplification, then we can find it like 5 minus 2 is 3 plus 4 is 7. Okay. We get 7. And Similarly, minus 10 plus 7 is minus 3, minus 3 minus 6 is minus 9. And then 0 minus 1, minus 1 plus 2 is minus 1 plus 2 is 1. So 7 minus 9, 1 is probably the solution if I have made the calculations as correct. So in
You
this
made mistake.
and
6 by 2 is 12.
in
In the second row, you made the mistake.
the second maybe a mistake. Okay, so it will be minus 2 times 5 plus 7 times 1. So minus 2 times 5 is minus 10. Minus 10 plus 7 is minus 3. Minus 3 minus 12 is
Minus 15.
minus 12 is minus 15. Okay. Yeah.
There is a mistake in B. Like you had to write minus for X, or like for B3.
Okay.
Yeah.
Okay. So it was minus 2, and minus 2. Anyway, so anyway, you can find it. Okay. So the process is the same. Okay. So let's you can also correct by yourself. That's no problem. So main thing is the procedure that you understand. Okay, so how about yeah, okay, I will skip that transformation part as of now. Okay, so yeah, there is some yeah, one example. Okay, example. Let's change the color to blue. So suppose if we have a matrix A, 2, 0, 0, 0, 0, and 5, 4, 3, 2. If we have a matrix such as this form, so for example, in this case, in the first row and first column has all values as 0, except one value. Okay. So in this case, there is a kind of a shortcut to find its inverse. The shortcut is that we can partition, and we can partition these matrices like this. So this matrix then now become a component of 4 parts. So these components will be called as A11 and 0, 1, 2, and 0, 2, 1, and then A22. Okay. So in this case, these 0 will remain as it is. Their inverse, if we want to find its inverse, these zeros will remain as it is. So 0, 0 will remain 0, 0, 0, 0 will remain 0, 0. And this is a single component matrix. Its inverse is also its inverse will also remain the its inverse. For example, the inverse of 2 is like 1 over 2. Okay. So its inverse will become 1 over 2. So only thing will be that we will need to find the inverse of this matrix A22. Okay. So, but the A22 is like a 2 by 2 matrix. So we can find its inverse by this formula. Okay. So it will be 5 times 2 minus 3 times 4. And then that will be 2 and 5 will change places. So 2 will be at the 5's place, 5 will be at the 2's place, and then 4 and 3 will change sign. Okay, so in this case, what we will get is 5 times 2 is 10, 10 minus 12 is minus 2. So it will be minus 2, 1 over 2. Okay, it will be 1 over 2, minus 2, 4, 3, minus 5. So by this approach, we can write its inverse like this. So this is the 2. So 2 divided by 1 over 2. Its inverse will be, so we are taking 1 over 2 as common. Okay, so the inverse of 2 is 1 over 2. So from 1 over to 1, we will take it common outside, so it will be 1, and then these 0, 0 will remain same, 0, 0 will remain same, and then this will be this, since 1 over 2 is common, so here it will be minus 2, 4, 3, minus 5. So this is called as the partitioning method to find the inverse, but this is only useful when, for example, you have 0 zeros in 2 rows, so it makes the job of finding the inverse by hand calculations a little bit simpler. Okay. Do you understand this?
May I ask a question?
Yes. Yes.
We can use this method if 0, 0 that is next to 2 is other numbers, yes?
Yes. So yes. So we can use this method only when first row and first columns have all zeros except one term. Yeah.
Okay, thank you.
Yeah. Otherwise, if all of the terms in the row and column will be 0, then the inverse will not exist. And yeah. So yeah, this is just the. So when we can make such partitionings, so then it's only is useful. So this is just like a supplementary method or something like a not very commonly used. We will not commonly use. So commonly we will use only the row operations for the methods. Okay, so the next method is the, but I will not describe it in detail. Just the introduction. It is called as the LU factorization. So LU factorization. So in the LU factorization, what do we mean? What we mean is that we will factorize if matrix A into its lower and upper matrices. Okay, lower triangular matrices and upper triangular matrix. So for example, if we will have a matrix something like this, A1, 1, A1, 2, A1, 3. So A21, A22, A23, A31, A32, A33. So it's, if you have something like that. So its factorization into upper and lower will be something like this. So lower factorization will be something like this. It will be 1, 0, 0, and it will be, say its component is L 2, 1, 1, 0, L31, L32, 1. Okay, so it will be a lower triangular matrix with the only three these values. All the diagonal values will be 1, and the upper the values upper than the diagonal will be all 0. And its upper triangular matrix will be something like this. It will be the maybe we can represent it by U11, and then U12, U13, and then it will be 0 in the lower part, U22, U23, and then it will be 0, 0, and then U33. So the upper triangular part will have the values in the upper part, in the area, upper area of the matrix, including the diagonal matrix values will be maybe the same or maybe the different in most of the cases. But in the lower triangular matrices, all the diagonal matrices will be all the diagonal values will be 1. So using this type of LU factorization can be used to simplify the process of the solution of the system of linear equations. So in this, when you simplify, when you make this, so the process of this, solution of this linear equations becomes a system of those matrices in which you can just simply apply the back substitution methods to solve the system of linear equations. So, but although this is this is interesting, and then it's a very interesting algorithm to find the L and U matrices. So that I will discuss in the next lesson. But anyway, this in the book, this method has been described as an optional method, but still we will do it over here. Right. All right. So that's all for today. So I will we will continue it on the next lesson.